Hello and welcome. I'm Bill Wake. We're here working on an old BASIC program from early 1980s. We've done a fair bit of work to transform it from the BASIC to a mostly Swift version. The drawing's still a little weird, but in general, it's a Swift version. The original was polling based, so it would go out to the keyboard periodically, like every time through the loop, basically, and ask it, "Hey, do you have a keystroke ready for me?" And if it did, it would process it. If it didn't, okay, and it would go on and then move the ball. So it's I guess from the logo you can sort of see it's like the Breakout trademark, Atari or whoever. But you get two chances to move the paddle for every time the ball moves. So if you have a keystroke down, then you get that chance. And we'd like it to be more event driven. I think even timing based is kind of what I'd say. But you should get a chance to move a couple of times before the ball moves. And this is a pretty big restructuring. I've done it a couple times for console app to event driven. And I've got sort of a formula, and we'll see how that goes. So the notion is the code, kind of at a very abstract level, it does some initialization, and then while not some condition, it does two polls. So it checks the keyboard twice. Hey, have you tried to move the paddle left or right? Or there's jitter, which kind of makes the ball go in a random direction. And then come back and then check again. Have you tried to move left or right? And then finally move the ball. And then, when the condition fails, either you're out of blocks or you're either out of blocks or you go past the end of the screen, then it exits and does whatever cleanup it wants to. And what we're trying to transform to is this notion of event driven. And what I've done is every little color coded piece on the left, hopefully the colors is contrast enough if you're colorblind, but each little piece on the left corresponds to a box on the right. So the initialization code, that first box, is kind of copied in. And then we have this notion of next, and we'll see how that comes into play. And event driven, there's some sort of main dispatch loop that's going to say, hey, here's an event. What should I do? And it's going to decide either go to the first poll. So this is why next comes into play. Do the first action, or do the next action, or no action, just move the ball. Eventually we come down, we check the condition. Are you done? If not, go back to the dispatch, and otherwise exit out and clean up the code. And what the struggle is, well, let's see. I'm not sure how to say what I'm going to say here. We have this block on the left, and it's kind of hard to work with. I mean, basically, I'm trying to turn this into a big state machine sort of thing based off the event coming in, rather than this sort of hard-coded polling loop. And I'm not sure. We're sort of destructuring the code to kind of make it go through each thread. So if you go through get action 1, the first poll, you're going to look and see, do you have a left move, a right move, jitter, or none? All right. And you'll do that processing, and then you'll say, okay, that was the first one. The next one should be 2. So you're sort of setting up some state machine type stuff. And then if it comes in again and wants to dispatch on a keystroke or whatever, it's going to say do action. Well, now next is 1. So this is sort of trying to enforce that 2 chances to move. And if there's nothing, if there's no action ready when the poll hits, it jumps right down and just does move ball. So we have to kind of take the pieces of the left-hand side and systematically move it into the right-hand side. And how systematically, I'm not sure what's going to happen. We'll see what it is. Okay. All right, let's get over to the IDE. All right, so I just ran the tests, and let's just run the app in case anybody's new. But you can see move paddle, move ball. All right, and move paddle digs in, finds the keystroke, and figures out what action takes place. All right, and so here's the while loop while the ball's less than or equal to screen end. Yeah. All right. Well, that takes a little bit to initialize. All right, so we see that loop, that condition. This first time thing we'll ignore for now. The two move paddles and the move ball. And let's go into move paddle. All right, so here it basically we've set up an action, left, right, jitter, or none, and we do that. So the front end, the GUI, the user interface, is talking to us in terms of which action. It used to use keyboard stuff, but keyboard isn't really a factor on iOS, at least for this game. So instead, we send a stream of actions at any given point, and if you click a button or touch down or touch up on a button, it can change the action. Okay, and we got some dead code we took out. Yeah, last time we did a little work to make sure when you're drawing, it was originally erasing the paddle and then redrawing it, and we could see the flicker because, as you can see, this is not a speed demon. I don't have any delays in this drawing code right now. I don't think. We've gone looking a couple times, but we do have some delay stuff that tries to simulate the given machine. But in this case, so when I hold down, and what you're seeing is it's going to 3 and then 2, 3 and then 2, rather than completely blank out and then go away and then redraw. And same thing on the left, 3, 2, 3, 2, 3, 2. Okay. So let's try this jittery thing. Yeah, see, we changed some directions. Yep. Okay. It might be nice to have some conditions on when you can jitter, but that's not there right now. Okay, I'm getting a little better at this game as we do it. But anyway, we're not going to play the whole thing. It won't take me that long to lose. Okay. So let's get in our to-do. Make sure we... Okay, make buttons work on touchdown. We did that last time. I didn't record that. And today is episode 9. Okay, so what we're going to try and do is transform from polling to event driven. Okay, and my picture, let's see. Well, let's unhide that a moment. All right. The picture, I mean, really the events ought to be coming through based on the event type rather than just these two boxes that represent the move paddle. I'd like it to say, hey, there's an event on the touch up button, touch down button, whatever those are. They set up some events, and I don't know. We'll see. All right. So my formula for this thing is, step 1 was isolate the output. That's more like a console app. We're trying to do some writing. So this process, I think the process is basically, my first step is identify pesky code. Okay. And you're probably wondering, what do I mean by pesky? Well, I think pesky code is code that polls, basically. All right, and I'm not quite sure the state we are exactly. Would you call this polling per se? It's polling in the sense that the front end. Let's see if we can show this. Okay, so there's a left arrow, a right arrow, and a jitter, and when you well, it's got a modifier on it, so it kind of monitors it. And what it does is it notices if basically it's got a drag gesture. We borrowed this code from somebody's example. Mostly it's the same, but we have a drag gesture. Normally the buttons in Swift UI, which is the toolkit we're using, only tell you about touch up inside the button. And instead we'd like this to be more like a an active control. If you push the button down, then we want to hear about it. And if you let go of the button, we want to hear about it. So this code does that and basically triggers your method, your chosen method. So it's keeping track of what you want to do when the button is pressed. Okay. And button pressed is a closure. So we're basically calling the closure with a Boolean to tell you if it's been pressed, if it's down or up, basically. And let's see if we can find there. Okay, so when you do it, we're going to call game.act and pass in the Boolean and the state, or the actual event that's triggering. Okay, and let's go here. Okay, so this one says if the Boolean is true, meaning the button was pressed, then activate that action. Otherwise, if the button was let go, turn it into the no action. Okay, so that's how that state gets set. All right, and all right, so identify pesky code. What else we got to do? All right, pull pesky code to the top level. We'll see what that is. But basically, I don't want to have a method that calls, A calls B, calls C, and eventually C says, "Hey, I'd like to read that input." We want to pull that up to the top level, and I don't know. I said add a read handler, and I'm not sure this stage applies, but we want to kind of like funnel the input through one place, basically, and we're gonna keep track. Well, the next stage is transform top level code to multiple entry points, and this is where language support would help. All right. And then I think we switch over to the new approach. Okay. I don't know. Some of this sounds like, a miracle occurs kind of thing. But anyway, so let's identify pesky code. Okay. And we'll look in blocked. Okay. So the pesky code is that paddle stuff, move paddle, which is not really just moving the paddle. It's also tweaking the ball. So it's a little bit misleading. Okay, so we have this code, move left, move right. So if the paddle left, then we're going to try and move left. If it's paddle right, we're going to try and move right. If it's jitter, horizontal actually affects the next ball position. And then none, we do nothing. Okay, but the move is identify it, and this is pretty well the only place that switches on the action. Okay, so woohoo, we did the easy thing. All right, so I'm going to copy this down, and we did that. Now I treat this kind of like there's a stack section up top. And then this is just sort of the list of stuff that gets done, kind of reverse order. Okay, now we want to pull the pesky code to the top level. All right, so I think this is mechanical. the question to me is, what's the top level mean for us? Because we got this while loop. Okay, but this is okay. All right, so let's inline this. Well, we're gonna have to do that manually. Swift Xcode does not inline. Okay, but this code was originally basic and shows its roots a little bit. But I think there's nothing going on here. Input, output. It's affecting a couple global things. I shouldn't say nothing going on input, output. It's affecting some global state. It affects the paddle, the screen, paddle, screen, or the ball position. But I've copied that. And let's inline it. And I'll leave the code down there for a minute. I don't know if this is a good place to go or not a good place to go. Let's see. Nothing is marked changed yet, so we started from a good check-in. All right, so here's the second occurrence of move paddle. And I'll paste this. Okay, so we've pulled, assuming you want to call this the top level, which I think is reasonable. We've pulled move paddle into every place where it gets used. Okay. And so I think that's this step. Pull pesky code to the top level. Now, what's going on a little different is we're still letting the UI system deal with the actual conversion of button up, down into action statements. And I don't know if that's the right way to go or not, but that's where we are. All right, add a read handler. See what I mean by that. Okay, I want things to flow through the same thing. I don't think that affects us. Extract the reads into a one-line call. Okay. Well, I guess I'm kind of verifying this code. Let's see what happens. Okay, so what I want to do, I want to say, do a read and tell me where the code should go next. All right, so I'm kind of looking forward to the restructuring. Okay, and I think the read in this case is sort of like that read of the word action. Okay, that looking at that is telling us. So I'm going to extract this into a method. Oh, interesting. I can't. Can I extract it to a variable? Apparently, no. All right. Well, let the action equals action. Okay. I'll extract it the hard way. Okay. And then maybe that should be the action 1, just because we've talked about 1 and 2. Okay. And I will do the same thing here. Probably could have just typed a 2 on the end there, hey? All right. Now, can I find action 2 in scope? The action 2. Okay, so I want this to be a read routine. Can I extract this now? No. What if I try this? No. Okay, let's just make a routine. Okay, so I guess I don't care about whether it's visible or not. This is going to be get action. It's going to take a target, which we don't know what that means yet, but we'll come back to it. And we're going to Well, the original was read line, but I don't think read line makes sense here. And then return the target. Get action returns int. Okay. Normally I would say read into buffer. Okay. I don't think we need a real buffer. An action here is local, I believe. No, it's got to be, it can't be. Here it is. Okay. Okay, so I think I'm going to say action is already set. And I don't know, we'll see. Okay, so I mean this is looking forward to the next step. So let's do the next step, and maybe I should put them in the other order. But the next step is let's see. We'll say we did this. Did that show? Okay, add a read handler. I think we want to say we did that. Okay, something's not quite. Okay, hopefully. If I hit save. Well, maybe when we take a break, I'll see if I can figure that out better. Something's off. Okay, add a read handler. All right, now we want to do this. Transform the top level code to multiple entry points. And that's the tricky part. Okay, so what we're going to do... Oops, let's get blocked. Okay, we're trying for this. So we have entry points that represent the paddle behavior coming in. So if an event came in that says do something, in other words, an action, because I think we've already got actions going, so that's fine. So an action comes in that says do move left. We should execute the move left action and return. And then if a move left comes in again, we've set this to 2, so we want to go here. I don't know. We're trying to make I think we can keep our condition the same. Let's see what we can do. All right. So I think the initial stuff is fine, and this stuff is the tricky thing. Okay, I think one thing is well, let me kick off test just to be a little safe. I'm looking at this first time delay code, and I think we can move it to the end of the loop and live with it. So basically this is your score goes down as your score is how many blocks you have left. And if you knock out some blocks, your score goes down, and you're delaying less and less. So the game gets faster as you knock away blocks. So the drawing code doesn't have anything slowing it down, but the playing code does. All right, and so we go through this and make sure you only do it at the first time, but you don't do it at the first time. But I think we're gonna make a change in behavior that I don't care about. All right, so at the bottom of the loop, after you move the ball, I think let's say the delay is here. Now we know it's not the first time because we've gone through the loop once. All right, the impact of this is going to be, it's not going to be visible to our test because they look at the screen. But the impact is going to be, the change is after the last time through, like say the ball moves out of scope, we're still delaying a little bit. So you're sitting there for an extra tenth of a second after the game ends before we tell you the score. I don't think it's a problem. It is a change in behavior, so I won't call it a refactoring. We don't need this variable anymore. Okay, so let's just do a run. And I don't know, these timing kind of things, I don't normally test them. Maybe it would be better to in this kind of case, but most things don't matter that much. All right, so we'll just let the thing lose. Okay, so the real game has 8 rows of blocks. I don't know how many vertical lines it has though, so it may matter. Okay, and we saw something when we rotated screens and played around with it the other day. It didn't really lose correctly, but I think when you're fresh, you don't have an issue. Okay, so that didn't seem appalling to wait that extra bit or anything like that. So I'm going to call this good. Okay, no harm in it. Oh, I should have mentioned all these other changes we did. Oh well. Okay. And I'm doing that just to kind of make the loop structure, just like the first thing that happens is move the paddle. Second thing, move the paddle. Third thing, move the ball. Fourth thing, delay. Okay. Now I want to break this into a kind of a state machine, and maybe that's the way I can start. All right, so what I'm going to do is I'm going to label this as code fragment 1, and this is code fragment 2, and I think 2 maybe goes into these as well. Well, maybe we should call these code fragment 3. I think that would be better. Okay. So we're going to turn it all into a big switch statement. Bottom line. All right. So the next fragment, next target, I think we'll say, is 1. And I think I can do this in small steps. So I'm going to switch next target. And this is case 1. And we'll just put this at the end. Okay. All right, so I've said, let's see. Switch must be exhaustive. Well, default does do nothing. It's even really a kind of a can't happen, but okay. Next target was never changed, right? Yeah, we'll get there. Okay, so I've made the whole thing. Excuse me. I've made the whole thing a giant switch statement with only one case that says, hey, next time you're going here, go to the first statement and do all the stuff. Okay, which seems correct. Okay, we'll let that run. And basically it runs the system once without changing anything like we just did. And then the second time it moves the paddle all the way to the right and loses almost immediately as well. And checks the board state at the end of those. So it's as slow as playing a game, unfortunately. We probably could change the delay to run a little faster with in test mode maybe. That would be a little change of behavior, but again, from timing perspective, I don't really care. All right, now what I want to do is I want to make this thing flow from stage to stage. Okay, so after you do your first move, I want to say your next target is 2. All right, so that was target 1, and we're going to do a break. And then we're going to do target 2. Okay. And then the same thing here. Next target is 3. And we'll do case 3. This gets a break. And this can have a break. All right. And after stage 3, the next target is 1. Because we're coming back through the loop again. Next time we want to start back at the top. Okay, otherwise I would let... Oops. Next target equals 1. Okay. If I didn't do this, target would stay 3 and it would just move the ball, and give me no chance to move my paddle. All right, and this time we'll do a manual test. All right, so we should see the paddle moving at a rate so it gets to the far right in plenty of time, and the ball keeps moving. Everybody gets their chance. Notice all we're letting the loop drive this still, and we could write a separate loop based on target, but I think this will work out okay. Yeah. Thinking may get me in trouble, but that's what I'm doing. Okay. Now, paddles seems to be moving the same rate it did. It's keeping up with the ball, getting a little ahead. All right. My aiming skills. All right. I might have been okay. But we've got our 2 paddle moves. We got the ball move. So I think everything seems all right. Let's see. You know what I'm going to do? Let's take out that delay just temporarily for ourselves and see what it runs like without it. So this is the equivalent of how does it look when you're at your maximum speed. But notice the delay was shorter, but the ball didn't get more chances to move. So theoretically, there's nothing keeping you from keeping up. Now this delay, I don't think I get it to do anything about. And I think it's just... it's probably the iteration overhead a little bit. Oh, that is moving, isn't it? Yeah, a little too fast for me. But, yeah, so the iteration overhead is moderate, but the screen, every character, well, every cell, everywhere, these are all individual text elements on the screen. So it's got about 500 or 600 text elements that it's keeping track of. And I think that's just bogging down the Swift UI stuff. Okay, so we'll keep these together and put it back in at some point. But I think, speed up our little testing iterations. But at this point, we've got this thing broken up into a big old case statement or switch statement. Okay, now... Okay, I don't know if in my write-up I wrote a little awk script that you would kind of simulate in your head to keep track of all the pieces and stuff, but our loop structure is so simple, I think we're okay. But what I want to get... All right, let's check this in. Oops. Okay. So we moved the main structure. I guess I'll include the last comment. The reads are at the top level, and we've made a state machine to keep track of code fragments. I think that's true. Okay, now I don't know what I did there. I don't really want any of this. Can I double click? No, that's IntelliJ. Okay, do it that way. All right. What my goal is now is I want to switch. See, somehow here I want to be switching on actions instead of case, the code numbers. And this is the part I'm less clear on how I'm doing that. Oh, break is optional. If it's the only statement, you have to have it. That's right. Okay, so I think these are optional, and I can say fall through if I really want to emphasize that. Okay, but I want to drive, and this is it's a sideways transformation. What we've done so far, I think I can justify it step by step in code. All right. But the change I want to make next is I want to say when you come into the loop, I want to get closer to that dispatch idea. Like, what's the action? And then you should do something. And if it's the action in case 1, then do this and set the next state to 2. That's still legit. Now, can I pull it out somehow? Oh, this is tricky. So I think I'm going to go from case 1, the case of targets containing the case of actions. I want to try and switch those so the action's on the outside. And when you come into the loop and you're saying, hey, what action do you have? What action are you up to? And I think, yeah, we'll have to see what we can do there. It may be some duplication, and then we simplify. But it's a little bit of a tricky move. So I think we're due for a break. So let's take a 2 or 3 minute break, and then we'll come back and we'll attempt this move of switching to these cases and see what we can do. All right, so I'll see you in 2 or 3 minutes. All right, welcome back. Okay, so I think what I want to do, and maybe I'll talk about it conceptually first, but I want to make it so that you switch on this stuff first, and then you're affected by case 1, 2, or 3. I can do this, well, one way I could do it, I don't think I have folding here. Yeah, I don't think I have folding in this thing. Can I fold this? No. Okay. Well, one way I could do this, and this is conceptually what we'll do. I could do this. I could say switch action, and then I have the 4 cases. Okay, now those are certainly the 4 possibilities. If I took this whole thing, okay, I'm going to cut it, and I'm going to paste it 4 times. This is my attempt at a legitimate refactoring that lets you do this. Okay, where did it go? Right. Jitter. And none. Okay. You may be saying this is horrendous, and I agree. All right, let me run it in the tests mode, and that should come a little faster. It still has to doodle draw the blocks, but the actual play should be zip and pretty well done. So I don't know. I didn't time it. It's all subjective, but we'll let the test run. So my argument is it's the same. Now the tests don't do a lot of actions, so it's probably not as fair, but at least tentatively, I think, since I'm doing the same thing in any cases, and my switch goes out to the outer layer, I think we can say it's the same. All right, so now that I've got that, I want to make things happen. Okay, if I come in and it's case left, in case 1, and let's pull this in now. I think maybe pulling it out was a waste. Okay, we know action is left, and we come in here and we look at what is action, and the only thing that's happening is the switch on the action. We do the case left, and then we do next target equals 2. So my argument is I know action is left, so this stuff is redundant. And all these are redundant because they can't happen. So the first one's, the test is redundant because it can happen, and this is redundant because it can't. Okay. So if you come in with left and it's case 1, you do a move paddle. Again, I'll inline this. Okay. So you come in, it's left, you switch on case 1, it's going to break out of this switch statement and send you back around the loop, and the target is 2, and the action is whatever the next action is by the time it gets up there. All right. Now, what happens in case 2 if it's a left? Well, we don't need to look at the action again because we already did. All right, we know these can't happen. And the next target is 3. Okay. And if we come in and it's left and the target is 3, then we just move the ball. We don't look at the paddle or any of that stuff. Okay, and we set the next target. All right. Now, let's see where this ends. Ends there. Now we do case right, and it's the same argument. All right, we're going to switch. Well, I don't even think we needed to let the action, right? Okay, we're just inlining this. Inline that. So pulling it out was a bad move, just to be clear. All right, this is case right. Well, it can't be left. It must be right. It can't be jitter, this or that, and the next target is going to be 2. All right. And then if the case is right and it's 2, then, well, we don't need to look at the action because we already know it's right. Oops, let me say that again. We know it's right, so dot right. Let's take this out. Now we know case right. We don't need the overhead of that. And this stuff goes away. Okay. Case 3, if it's right, then nothing changes. Okay. Now we're in jitter. In case 1 for jitter, we do this. And next target equals 2. We'll fix the alignment later. Okay, if it's jitter and we're in state 2, it's not this stuff. Not that stuff. This case targets 3. Okay, finally, if case 3 for jitter, we don't do anything special. All right, now case none. This is nothing is pressed. All right, so we'll skip down to case none. And nothing happens. Okay, so there's no action except to set the next target. Same thing here. None does nothing except set the next target. And then, okay, this does its thing. And that. Okay, so hopefully you feel like I justified it. I mean, it's kind of the slow way. I could have probably just moved it up and caught the cases and copied them in or something, but I tried to do it the legitimate small step way and hopefully not mess it up. All right, so I'll run tests first and then we'll run it and see how it feels. Now, it probably feels like we have duplication because I think, because we have duplication. All right, I don't think these comments are doing anything either. All right, tests are good. That's a good sign. All right, we'll do a run because it's tricky enough. I don't know. I suppose that tells you I don't trust my tests, and that's because I don't trust them. Maybe I'm just too lazy, but like I'm holding this down for X seconds. I'm waiting until it all draws and holding it down for X seconds. Oops. Okay. Well, maybe a delay would be more appropriate for somebody of my video game talents here. But I know it's 20 across, or 21. Okay. And okay, we got an error there. I may have to do this again. Ugh. We saw this before when I assumed it was a clearing out issue, but this, okay, am I going to do this again? I guess I am. I hate to. But on the other hand, I mean, it was 8 minutes or something, right? Let's revert this. Okay, what is puzzling me as it does its thing? I don't understand why it's bouncing off the bottom. All right. I did have one theory. We don't. Oh, this is not attractive, but I think the deal is we don't clear the screen ever. And let's look in here, environment. So we have this screen object, wherever it is, there it is. Okay, it's screen in minus screen start plus 1. Okay, so 53248 55295. It's spaces. Let me do another go. I think, yeah, see, I think I've got it running twice somehow. I don't know if we see the score. Yeah, I don't print the score. Okay. I'm reverting. I think well, I don't know what happened. That's why I'm reverting. Okay. Let's run this, make sure we can lose. And I don't know. There's this notion of screen end. Five 44140. Okay. Screen end. This is actually screen memory, and this is the visible screen. And I picked this name here because it's sort of the screen you care about or you think in terms of, but I really shouldn't use the same name here. But this one uses these, so this allocates more than this. So this only goes up to 54140. That's the part that's on screen. All right, let's see. Do we still have this error? So I don't think we did anything that should have affected this behavior, but must have, because the acceptance test I don't think would work. Okay, that's what's supposed to happen. So I messed something up. Okay. Let's try this again. Okay, so I'm trying to say switch on the action. So let's get this put back in. I said these don't matter. This is useless. Okay, so can we do this? Switch next, action of case left, case right, case jitter, case none. Okay, now I'm going to try and do this in a copy at a time rather than all at once. So I'm going to copy the switch statement into case left. Switch must be exhaustive. Did I not copy the whole thing? All right, let's try and be careful. Switch action of this. Okay, yes, I want executable statements. Now switch next target. down to here. I think I went one too far. All right. This. Case left. Okay. Next target in case 1. I know my action is left. I take out the stuff that's here, keep the next target statement, and break. Okay. Case 2, I know it's left. Keep the action. Take out that. Leave the next target statement. And break. Case 3 doesn't need to switch on that stuff. Sorry, if I come in case left, I come in dot left. We're in state 1, do this, state 2, do that. Do we do anything in state 3? I think that's legit. Okay, move ball next target equals 1. All right, let's take the next case. Well, how can I do this? I want to be stepwise on it. All right, we're going to just do a default. All right, and this time we'll take the rest of this stuff up through here. That's the while loop, and we'll move into default. Okay, so I'm saying if it's paddle left, do the customized stuff. If it's right, jitter or none, do whatever we did before. All right, let's see if this messes things up. And I'm just going to run only moving to the right and see what happens. Okay, so moving only to the right. We're going to see if we can lose the game. Okay. And I think if I do it again, I don't know, there may be junk down there. So my theory is the ball is down there. Okay, now move to the left. I think we demonstrate that it's still okay. And if I take this out, all right, my two suspicious things. If I'm in left, action left, I don't think I can be in state 3 here. I think I'm not supposed to do anything. But okay, so I've commented this out. Case left should have one executable statement. Well, okay, let me comment the whole thing out. Well, no, that's no point. Redo paste. Okay, so what is going on? I don't know if I should do this with thinking, debugging. All right. In our original code, if we come in, next target is 1 and the action is left, we're going to move left and set next target 2 so we can try and move the paddle again next time. And we exit the loop. We come in the action. Well, let's say they kept it on left. All right. Now we move another one to the left, and next target is 3. We come in again with action left, and we're at 3. Like by now, you should just move the ball. All right, and then move back to look for another one. I don't know. That all seems okay. Why would that make it invincible? Let's make sure everybody's breaking who's supposed to break. Well, I mean, this kind of break. So next target 3, you come back in, and left is still held down. We say, okay, move the ball. Next target is 1. All right, we go through the rest of the loop. It comes in again. It should say action is left. Next target 1, do an actual move. Why? Maybe I should be focused on the condition. Maybe this condition is not correct. Ball less than environment.screenEnd. Okay, I'm gonna put a print in. Actually, I want to make sure. What have we got going here? The startup situation. Draw initial screen. Okay, you have 24 rows, 24 columns. You draw the top. Starting at screen start. Then starting at screen start plus screen distance times the rows. Screen height minus 1, 24 minus 1 is 23. So 0 to 23. Well, 0 we drew, and then 1 to 23. Is that right? 1 to 23. Yeah, so it should be 0 to 23. We draw 0 here, 1 to 23 here. Okay, the blocks, there's no way they're deeper than they should be. And where's the paddle start? All right, the paddle start. Paddle is 0. Paddle is screen paddle min. Okay, which is here. Okay. Screen start. So 0 plus 23 times 32, which is the row distance. Plus 1. Okay. Well, what I think I have is I'm going to print the ball at any point. I'll stop the game. Well, we'll check it when it's there, and I guess we can. Let's check this thing too. Make sure everything's what we think it is. All right. So my hypothesis I'm testing is there's something about the way we're tracking the ball versus the screen end that lets it bounce. Okay. lets it bounce on the very bottom even if the paddle's not there. I wonder if we did something here, but we're putting space character in. We're writing one paddle character and removing one paddle character. We'll take a look at that. We should see it if it's not there, so I don't think that's an issue. All right. I'm going to start the thing up, not move, and go back and hit stop as soon as it bounces off the bottom. Now, it may be that something in my switch statement move, I don't know what it did. Maybe it let the ball move twice or something without anything happening. But we're coming in with .none. And don't touch anything and let it go. And this should die. Okay. Let's do it again. This time I'm going to execute at least one left arrow. And if we do, that pretty much proves it's the left arrow thing. Yep. All right, let's stop. Horrible numbers. All right, I guess we want to find the biggest one. All right, so what is all that? Screen end. Oh, that's the first run. Screen end 54140. That sounds correct. Based on this up here. Screen end 54140. Okay, so 90, 904s, 811, 780, 781. Oh, we want the biggest. 90, 59. So it's decreasing. 539, 35, 53904, 873, 842, 780. So that's the top. 54010, 54073, 54100s, 54101. Okay, this is the ball. That's the bounce. Okay, because it decreases by 32 plus 1. 54101. So 54101 is less than 54140, and yet it bounced. And I don't even think it should bounce on a white space, so that's really puzzling. Now, I don't know if I can stop. Let's see. Can I make a conditional breakpoint? Let's stop when ball equals 54101. Ignore. Well, let's take the first one. Okay. Let's see if we can make that go. So it died correctly when I did not move to the left. So there's something in that moving code that's doing this. It's like, am I getting a two chances to bounce or something? Am I? Why am I stopped here? With a spinny ball. Maybe it was just setting up that first time through. I don't know, I had a very odd pause there. Ball 54101. All right, so I think something happened. I don't think I had a chance to move. It basically froze up waiting for that conditional break point with a very frozen looking screen that I couldn't touch. So I don't know. Okay, now move left. Huh. There it goes. Okay. The ball. I hope that's reconnecting. All right, so at any rate, the ball is now 54101. That should be the first time. Okay, and we're just going to do some execution. Okay. Next target is 1. Action left. That was very odd. Next target 2. Break. Okay, let's print the paddle. Right. Okay. Next target should be 2. Okay. Move left. I guess. Action none. Okay, case 3, move the ball. Five, 4, 101. Let's step in there. Vertical is minus 32. If it's a space, so 54101 wants to move to 54069. All right. So it's bounced already. So I think I should have stopped at the second one. But we're due for a break, so I gotta clear my head on this, I guess. But we'll take 2 or 3 minutes and come back and figure out what's going on here. All right, welcome back. Okay, so something is making this thing flip before its time, and my concern is we're ending up doing this twice. Like somehow we're bouncing and we reverse the direction, and before we can move again we check it and say, oh, let's reverse the direction again. All right, so I'm going to take this case out for a moment. And we'll do a run. And I don't know, maybe we'll try it just kind of thinking our way through what should happen. Okay, I'll do both right and left. Okay, do it again. I'm going to hold it down. Okay. Let's clear this and continue. Oh, sorry. Too many environments this week. So my plan is move right and then move left and hold it down. Go again. Aha. Okay. Well, so where I think we are, we switch on the action, and no matter what the action is, we do the original case statement. Okay, so that means something is definitely broken. All right, so I'm going to revert again. Yeah, so I saw this failure the other day, and I put it down to the fact that I saw it like I'd flipped the screen right and left, rotated the screen, and I thought, oh, maybe, it left some stuff in bad memory places on the other. What's going on here? Okay, we reverted. All right, so blocked switches on the target, and then inside there the action. Okay. Let's run. And I'm showing bursts of like super high CPU. I don't know if there's something going on there. So let me take that off. All right, so I'll move right. And then I'll move left and hold it. And repeat. Okay. Whew. It's not our transformation that's doing it. It's something in the code. All right. Now, what's going on? All right, I'm going to commit this because I think this inline extracting was not helpful. And I don't think it's in the way of what we're fixing, but okay. Let me do a run. Now I can't tell if it was okay. That test is running a lot faster. I can't tell if it was the rerun. It seemed like we saw it fail once on the first run, though. And I don't know. I think my theory is something about when I'm holding it down, and it's exceeding its thing, that lets it flip it or something. Okay, I'm held on the left border. No error. I run again. And it's not stopping. Okay. It's the second time. I mean, I've definitely seen it most of the time on the second time, but I do believe there's been times it's the first time. And you can actually get a jitter that goes straight up and down. The ball seems more flickery to me than it used to. That's probably just because it's running at maximum speed. And this is the part you're waiting for as a player of this, right? Just chunking away on your stuff. Yeah. But have no fear. All right. You get better scores this way, but I don't think that's enough. All right. So what's the scenario? And then we can go back to the basic and see if it can happen there. We don't have a real way to run the basic. Well, okay. What are my theories? One is it's environment, in which case this is the wrong place to work. If I do peak, it's less than memory start and memory end. Screen memory start is environment.screen. Well, I should make this screen memory start, but okay, screen memory end. That's the peak. If you're in there, look in the screen address minus screen memory start. If it's in there, write the value. Now, there is something in the original program. Let's see if I can find it. Yeah, this. It's attempting to clear the screen by writing out, well, 25 blank lines. But the reality is, I think the reality is the print statement can only get to the visible area. Okay, we do a bunch of stuff to make sure that it's starting. It's using screen end, not screen memory end. Okay, so the visible part is being redrawn. I don't know what my theory is though. It's like I could see if it bounced and hit the same place where the ball was in off-screen memory, it would have a chance of doing that. Okay, so one theory is let's take some notes. Okay, so to do fine. Okay, to do. Okay, so one theory, we're writing past the visible area. And then the ball bounces off that. Okay, and the fix would be something like doing a real clear screen, physically flush all that memory. This is simulated. All right. Another possibility is there's some combination of conditions that lets the ball bounce twice and improperly flips the vertical direction. Okay, so if you came down and you realized, I guess if you're heading down the screen, you're increasing the memory position, and you increment well, let's see, where's that test, right? This is move, not paddle, move ball. Okay, wherever you are, you poke a space where you are. Okay, so we can see the flicker right here. Poke ball space, poke ball regular character. Move ball vertically. Position is ball plus vertical. So normally the vertical is going to be 32. If the next position is a space, we set it to the next position. Otherwise, we're hitting something that's not a space, and we flip the vertical, so it's moving up. With a positive 32. Okay. If the peak of the next position is the block, well, that doesn't seem any different than this, right? Okay, we set it to move vertically. It hit something. Perhaps it hit a wall or a paddle. If the peak is, if it's a block, we put a space there, decrement the score. Okay, so if it's a top wall, we just bounce. If it's a block, we want to bounce and then go the other way. All right. Then move horizontally. We move that. We check for space. We flip the horizontally. And we decrement the score. And there's definitely duplication in here. Okay. But what would let us come through twice? And it could be 3 times, but all right. You can see why we need a jitter. It got stuck in a little bit of a loop, a physical loop. All right, now like the original game, I don't think it did anything when it cleared it. Or maybe the original game, you cleared it once and it took you to the next screen, and then you cleared again and you hit reset when you're done, I guess. Notice at some point it cleared out the paddle. All right. I don't have any more theories. All right, but yeah, there's a loop. Let's do a little jitter. Okay. All right, around one more. I'm trying to think of a situation where I could force the error to occur on the first time the game is run. If I can't do that, then maybe it is a screen issue. I don't know how anything got written down there is the problem. We started off with spaces. As far as I know, we're only drawing on the screen. You stop. Okay, let's take a go at. Let's give our environment. Well, we can make our own clear screen. Let's try that first. All right. So when you hit go, that's in here. Okay, we print blocked. Let's clear. Let's say for I equals, well, let's do for env dot screen memory Okay. Forgive me. We're just 32 is space. I don't know if we have a variable for it here, so I'm just using my knowledge. All right. I think the effect should be we get hello blocked. We might see it flicker by, and then not see something. What's wrong with poke? Oh, I didn't say for each. Okay. Int has no member for each. Hoping this is a range. So we'll run it once, we'll run it again. Hopefully. Okay, and then, oh, something's not going right. It should erase that at some point and then scroll up. And maybe it's just super slow because we're touching, 32 by 32 now. 2 to the 10th. 1,000 memory locations. Or something is not right. Can I break here? $53901. Maybe we're just continue. Maybe I'm not patient enough because it's 5.4 or something. Yep, there it goes. All right. So it got to the top, or to the bottom of visible memory by now is erased, but we're still erasing the other half, which is invisible. Like, wowzer, is that slow? There must be more notification than I'm aware of on this or something. It seems... Well, I could probably... make the screen be rows of strings. Because right now, I don't know how it's deciding. I think maybe it's diffing that whole big block to find out, oh, these 3 squares changed. If I did it by line, would it run faster? Okay, yeah, that took a while. There's certainly a faster way to clear memory. Okay, now it's going to take a while again. All right, so another minute. And we will see this part erase. Yeah, there it goes. If I move it to the environment, I can do it in one assignment statement, right? I can just allocate a new array. And that's kind of a one-time thing. I imagine you'd get one update. Maybe it would throw it away. I don't know. It should be erasing all of them. There it goes. So kind of the same speed as drawing them. Okay, that's the visible. Now we got the invisible. I gotta be ready. Well, maybe next time we'll do some performance stuff because this update is very slow. Didn't realize it'd be quite this slow. It's got to be there soon, though. There it goes. And I don't know if the 1982 BASIC was quite this slow, but it was slow. All right, please do not. Yes, okay. So I think we've established that's the reason that there's some junk memory out here. I'm not sure why. It would be interesting. I almost want to catch places that are outside the visible memory. I mean, it should still write it. So here you can see run a main thread. So we have to do updates of monitored objects in the main thread. So this is done there. That lets this trigger, because screen is a published field, it lets it notify the UI and do the UI job. Okay, oof, goodness. Screen end cannot be used. Yes, insert environment. All right, let's try that again. I hope it's still streaming. It looks like I'm going to have 2 recordings and have to do some gluing there, so... All right, so this is our basically environment. It's a library in Swift Package Manager. All right, doesn't. Okay. Doesn't obviously break anything anyway. Okay. We'll we'll do a commit. Okay, and then we'll do a tag. We're up to 24. And a push. Include tags.